This is a blood typing lesson from biology. You have three types of blood alleles. IA, which is a dominant allele, IB, which is also a dominant allele, and little I, a recessive allele. So if IA or IB is showing in an allele, in a gene, then this little I will not show. Type A, you need to have IA, IA, or IA with a little I. To be a type B, you need to have IB, IB, or IB with a little I. To be a type AB, you must only be IA, IB. To be a type O, you can only have two little i's. We're going to find a person's blood type with using this example. A female with a type A blood has a child with a man who has AB. Can this couple have a child with type O blood? First, we need to find the important information. It says the mother is type A, but it does not tell us whether she's homozygous, meaning she has identical alleles, which means she has IA, IA, or she's heterozygous, which means the different alleles of the same trait, so she can also be IA with a little I. It does tell us the father is type AB, so he can only be IA and IB. To find blood types, you must do a Punnett square. We're going to put the mother's alleles right here and the father's right here. We're going to start with the homozygous first. To do the first Punnett square, which is this one, you need to take one allele from the mother, we're going to start with this one, and one allele from the father, this one. A hint, you might want to put A's before B's when it comes to blood typing. So this box right here will be IA and IA. We're going to take this allele from the mother and this one from the father for this allele box right here, and that will also be IA, IA. We're going to take this first allele from the mother and the second allele from the father, and we will come up with this box right here, which is IA and IB. We'll take this one from the mother and this one from the father, and we will come up with IA and IB. To do genotypes, genotype is a gene or allele that determines a specific trait. With this couple and this alleles, we have a 50% chance of IA and IA, and we also have a 50% chance of IA, IB. This will show you, looking at the Punnett square, you see the 50% of IA and the 50% of IA and IB. Phenotype. Phenotype are physical characteristics that show in a gene, that show in an individual from a gene. So, if we look back at what makes a blood type, which genes allow you to have a blood type, you see IA means you have type A, and IA and IB means you have type AB. So this couple has a 50% chance of a child being type A and a 50% chance of type AB. This is going to be the child's phenotype. Now we must start Punnett square 2 with the homozygous traits. We have the mother as IA with a little I, and the father as the same with the AB. For this one, it's going to be IA, IA, and we're going to put it right here, which is IA, IA. We're going to take this allele right here and this one right here to come up with the next square, which is IA with a little I, and so on and so forth. So here we have IA, which is the mother's, and the IB from the father. IB, father's, and the I from the mother. For this genotype, we have a 25% chance of IA, IA, a 25% chance of IA with a little I, a 25% chance of IA, IB, and a 25% of IBI. If you see, all the squares are different, so that's a 25% chance. If they all were the same, then it would make it a 100% chance. For the phenotype, you have a 50% chance of type A. This one, IA, is going to give you a type A blood person. IA with a little I is also going to give you a type A person. So you must add these two chances up together, because no matter what, it might be different genotypes, but it's the same phenotype. You have a 25% chance of type B and a 25% chance of type AB. From this one is your AB and this one is your B. So the answer is a mother with type A blood and a father with type AB cannot have a child with type O blood, because in neither one of the Punnett squares did we come up with a child with type O. So this proves that under no circumstances can any parent who has a type AB ever produce a child with type O. Because AB are two dominant alleles, no matter what, the child would have either IA or IB, no matter what. To be an O, both parents must be heterozygous for A or type A or type B. And this concludes our lesson.